Okay, in this question we need to compute the mean, median and mode for some data that are given. The data are about the number of total vetoes exercised by the past 20 presidents in the United States. And for example, this means that the president gave 6 vetoes. This means a president gave 132 vetoes from the 20 presidents. Okay, so we need to calculate the mean, median, and mode for the total number of vetoes. And in part D, they already made a grouped frequency distribution for you, and they want you to compute the standard deviation. Before I solve anything, I just want to make one point, is that look here at the grouped frequency distribution. We have chosen to make 5 classes. These are 5 classes. You see, one class is 6 to 54, another class is 55 to 103, then 104 to 152, 153 to 201, and then 202 to 250. I just want to remind you how to make these classes. So first you look, I have the highest number of vetoes is 250, or the highest data is 250, the lowest one is 6. So 250 minus 6, this would give you 244. And since you want to make 5 classes, and remember, we usually make between 5 to 20 classes for data, depending on how many data we have and so on. But since we chose to make 5 classes, we will divide this range by 5. So remember that this was the range. The range is the highest value minus the lowest value. So range over the number of classes that you want. So you'll get 244 over 5, and this would give you exactly 48.8. If you round it, a little bit, you'll get 48. You can say 48 or 49, but you can choose 48 in this case, because you will see that each of these classes, for example, if we look at the first class, what's the class width? The class width would be 54 minus 6, which is this 48. This 48 that I have here. That's how the class width is computed. Okay? Notice that all of them are 48 if you compute the class width. And for the midpoint, since the class width is 48, it means that the midpoint would be the lowest value plus 24, because 24 is the middle of 48. So if you see here, for example, for this one, 6 plus 24, and let me, instead of saying 24, I will remind you, it's the middle. It's 48 over 2. 6 plus 24 is 30, which is the midpoint of the class. But also another way to get the midpoint of the class is just, let's say for the same class, for this one, you just add the numbers, take the average of 6 and 54. 6 plus 54 over 2, this will be 60 over 2, which is 30. This is the midpoint of this class. And you can do it for all the classes to get the midpoints of each class. Okay? So this is something for you to understand how this grouped frequency distribution was made. It's not part of the question, it's just I'm explaining it to you again so you know where these numbers are coming from. Also, before I go to the next page, notice that this, for example, number 13, this is the frequency of this class, 6 to 54, meaning that we have 13 presidents that gave vetoes between 6 and 54. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then after that, we will be outside the 6 to 54 interval. So that's why we have the 13. And then between 55 and 103, they say that we have 3 presidents who vetoed this. So this will be 66, 78, 82. Those are the numbers that lie between 55 and 103, and so on for the rest of them. So now I'm going to go to the next page to solve the questions one by one. Now I put the data all in one row to make it easier for you to calculate mean, median, and mode. So for the mean, you remember mu. In this case, it's population because we are looking at all the presidents, the 20 presidents. So we are not choosing a sample of those 20 presidents. We are just looking at the past 20 presidents and how many vetoes they gave. So this, you consider it as your population. So for the mean, you will use mu. And so mu is what? The mean is you add up all the data that you have, add everything up to the last one, and divide by the total number. And we know that we have 20 presidents. So 20 over 20. And if you do this, I will just write it. 6 plus 21 plus 30. I cannot write all of them, so I will put dot, 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 plus the one before the last 181 plus 250. All of this, you divide it by 20, and you will get exactly 71.35. So this is the mean for this question. Now I'm going to just erase this stuff so that we can compute other things. Second one is the median. The median, we can write it either as median, or if you remember when you do quartiles, you can use Q2 for the median. Q2 equals, let me say, equal the median, which is, the median is the value that is in the middle of all the values. So we have 20 values, starting at 6, ending at 250. Those are 20 values. So where is the middle? Since it's an even number, you will count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 and 11, those two numbers lie exactly in the middle of this list. So you will take these two numbers and take their average. In this case, it turned out that these two numbers are the same, so you will just add them and divide by 2, and that will give you the same number, of course. So 44 plus 44 over 2, this will be 44. That will be the median. And I will just point out one thing, is that let's say that we had 19 presidents, we didn't have this 250. This would mean that you have 19 numbers here, from the first to the last. And for this, it's very easy. Just the 10th number is the middle. So you'll count 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this would be the median for you. Because after it, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 before and 9 after. So for odd number of data, it's easier to compute the median. If it's an even number of data, you take the average of the two values in the middle. Okay, so let me erase this now and go to the last part of this page, which is calculate the mode. Now, let's see, what was the mode? The mode is the value that you see that is repeating the highest number of times. So, for example, we see that 37 is repeating 2 times. We see also that 44 is repeating 3 times. Is there anything else that is repeating? If you look here, I don't see anything else that's repeating. And so forget this because it's repeating only 2 times. The one that is repeating the maximum amount of times is 44. It's repeated 3 times. So the mode is 44. Okay? And so this is how you compute the mean, median, and mode. I just want to tell you something, that this mean here, this, we call it the mean, of course, but it has something else. You can say this is the true mean of the data. Why am I saying true mean? It's because you took all the data that you have into consideration when you were computing this mean. Now, remember just what I said now, because the next question we will compute the mean again, but using grouped data. So here, look, again, we have the frequency distribution here with the midpoints, and I want you to understand something. Now, for this class, from 6 to 54, instead of using the numbers, the 13 numbers, the 6, 21, 30, 31, 37, 37, 42, 40, 39, 42, 43, 44. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Those are the 13 numbers that you have here. Instead of using all of them, you just take the midpoint of this class, and the midpoint is 30. So it is kind of, you ignore all the numbers between 6 and 50 and replace them all by 30. It's like all of them now are 30, 30, 30, 30, dot, dot, dot. Even this 50, you call it 30, okay? And the same thing here. The midpoint is 79, so you consider that these three values are 79, the ones between 55 and 103. And 128 will be once, and then 177 for this class, the class that is between 153 and 201, and then 226, you will take it as the midpoint of the last class that we have. So in other words, this means that our data now, instead of having the numbers that we were given initially, this list of numbers, instead of them, now the numbers are 30, 30, 30, 13 times until the last 30, and then 79, 79, 79, 128, 177, 177, 226. Now, it's kind of, we ignore now all these numbers and replace them by the midpoints. Okay? And so our mean now, mu, for the group data is going to be, it has a formula, of course. You divide by the total number of frequencies, and you multiply by the frequency times the middle point, x mid. So this is the formula, of course. This formula will never change for group data. So now you will have 20 below, and then above we will have 13 times the midpoint of the class is 30. So we have 13 30s, as I told you, and we have 3 79s, 3 times 79, plus 1 times 128, plus 2 times 177, plus 1 times 226. And so if you compute this, okay, I'll do it again. 13 times 30, okay, plus 3 times 79, plus 1 times the midpoint, 128, plus 2 times 177, plus 1 times 226. That's how you compute the mean for group data. You might ask me, but they asked for the standard deviation here. But remember, for the standard deviation, you need the mean. If you don't have the mean, you cannot do the standard deviation. So now, if you calculate this thing here, you should get 66.8. This will be, I can call it, this is not the true mean, but it's the mean for the group data. The grouped data. Well, let us compare it to the mean that we had before. Now, the mean for the group data is 66.8. What was the mean that we computed, the true mean? is 71.35. Notice that they are close numbers to each other. So this is something nice. It's telling you that instead of looking at very different numbers, if you make them into classes and then replace each class by the middle point, then you can still compute the mean and get something that is close enough to the true mean that you can get. And of course, the question here is asking about the standard deviation. So we can compute the variance first. The variance is sigma squared. So let me just to remind you, standard deviation is just sigma, but this is the variance. And if you compute the variance, once you're done, just take its square root, and you will get the standard deviation. So instead, let me write it here to remind you that standard deviation sigma is equal to the square root of the variance, which is, of course, square root of sigma square. The variance, we call it sigma square, which is sigma. Okay? So sigma square, it has a formula. The formula for sigma square is this. Divide by the total number of people, or for votes, whatever, and on top you have the sum. Of course, in this case, because we are talking about group data, you put the sum of the frequencies down, just like you did it with the mean. And on top, you multiply the frequency by the middle point, x mid, minus the mean squared. A good question now you could ask is that the mean that I use here, is it the true mean that I calculated here? The answer is no. You use the mean that you computed from the group data, which is this one. This is what you will put here. And you start putting the middle points one by one. So 30, you put it here, subtract the mean from it, square, and then multiply by its frequency. Okay? So I will do the first few of them. This will be the sum. The sum of the frequencies, as you know, it's 20. We have 20. And then this will be 13, the frequency, times the first midpoint is 30, minus the mean that we got, which is 66.8 squared, plus 3, which is the second frequency, times the midpoint. Second midpoint is 79, minus the mean is 66.8 squared, plus dot, 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 plus the last one that you will have. I will just write it here, which will be 1, it's the one here, times the midpoint 226, minus the mean, which is 66.8 squared. Okay, and then you divide the total thing by 20. So let me fix just what was here. This is times 13 times, what was the frequency? 13 times 30 minus 66.8. Okay, and if you compute this correctly, you will get approximately 3,571.5. Please check all of these calculations on your calculator. If you find a mistake, let me know, or let your instructor know if you are not in my class. Okay, but this was sigma square. To compute the standard deviation, which is sigma, we just take the square root of this number here. So I will do this on the next page. So you can say here, therefore, the standard deviation sigma is the square root of the variance that we just computed, which is the square root of 3,571.5, and this is approximately 59 59.8. So here is our standard deviation. Okay, I will write on top of it, this was our standard deviation. Okay, this of course answers the question, but still I want to add one more thing to make you confident in your answer. This number that we get here, I want to show you a way to know what it should be or something close to it before you even start all of these computations, even before you do this or this from the beginning. You know, you can go back to the question and say, what is the range? The range is the highest value minus the smallest value. So let me go to the page here and compute the range. The range is the highest value, which is 250, minus the lowest value, which is 6, and this will give you 244. We all know how to compute the range, but what is the idea that I'm trying to tell you here is that there is a rule or a way that statisticians use. It's called the range rule of thumb. Rule of thumb. And what does the range rule of thumb say? It says that the standard deviation is approximately the range divided by 4. Okay? So now, what is the range divided by 4? Let's see. The range is 244, so you take 244 and you divide it by 4. If you do this, you'll get exactly 61. Okay? And what was our standard deviation? It was here, 59.8. Notice that it was very close to 59.8. That is the true standard deviation. So even though you cannot, of course, use this rule all the time to find the standard deviation, you need to use, you know, the mean of the group data, then compute the variance, then take the square root of the variance to get the standard deviation. Yeah, but also, this is nice that once you get an answer, you can at least know if it makes sense or not by using the range rule of thumb, which is here, that the standard deviation is approximately the range divided by 4. And remember, the range is always the highest value minus the lowest value in your data. So you get 244 when you divide it by 4, and 4 is a number that doesn't change. This is always in the rule. It's not changing, okay? It's range over 4. It should be the standard deviation. And you got 61, which is very close to the standard deviation that you got from the harder or longer formulas. And I hope by now you understand these things much better. And this will be the end of this question.
In fact, there is a small mistake that I made in this video. If you go back to what I called the class width, is actually called the class interval, not width. This is called the class interval. And if you want to see how to calculate the class width, this class width is equal to, you can do it in many ways. You can take the lowest value of class minus the lowest value of the class before it, or highest minus highest of two consecutive classes. So in this case it will be 55 minus 6, which is 49. This is what is really called a class width. I called the class interval class width before, so just forget this. And everything else is correct.